Yes, I'm ready.
Okay, so on behalf of the physics department, I welcome Professor Sujan Sengupta for this talk. Let me talk about the department briefly to our guest. So at present, we have 20 faculty members in the department, and we run integrated MSc program. And apart from that, we also run minor in physics program for BE students and also PhD program. And we have a strong group in condensed matter physics and high energy physics. And the department is supported by DST under this DST FISH program, and we have 35 students who are enrolled in the PhD program. So with this, I stop about the department overview, and I invite Professor Sujan Sengupta to deliver today's talk. So over to Professor Sujan.
Okay. Good evening, everybody. Thanks to Professor Rajesh and the Physics Department of BITS Pilani for inviting me to talk with you. I'm sure that most of you have heard and are curious about aliens or extraterrestrial intelligent life. Some of you may already have started believing in the presence of alien at the Earth by seeing pictures and videos of UFO or unidentified flying object or weird animals that suits our imagination of aliens. But science is a fact-finding process and not based on belief or faith of even majority of people. Science needs unambiguous evidences to establish facts, and testimony of eyewitness is never considered as evidence. So after 6 decades of hectic search, astronomers have failed to detect any signal from the space that may be considered as communication from aliens. Initially, I thought to tell you the search for habitable planets and signature of life, not necessarily intelligent life, but even simple or nascent life in planets orbiting stars other than the sun. But then I have decided to include the search for extraterrestrial intelligent life as well. So today I am going to explain you with an analysis of our existing scientific and knowledge why an artificial signal or any other evidences implying the existence of alien civilizations remain elusive to us. That's Earth, our home, the only planet, the only place in the vast cosmic arena known yet to harbor not only life, but also intelligent life and civilization capable of communicating with alien civilization. However, in the 4 billion years of evolutionary history of life on the Earth, the oldest ancestors of modern human, Homo erectus, appeared on Earth about 2 million years ago. And the human species known as Homo sapiens appeared only 300,000 years ago. Cultivation started about 10,000 years ago, and uh, the oldest urban civilization, the Sumerian civilization, existed only 5,000 years ago. But Sumerians and subsequently Babylonians, Egyptians, the ancient Greeks, all were curious about and imagined the existence of aliens and noted down their imagination in painting, sculpture, and mythologies. People in this ancient civilization believed that intelligent creatures and gods and goddesses lived in the celestial objects that were visible in the night sky. In other words, they believed that life exists in all celestial objects in the sky. But about 2500 years ago, Greek scholar and philosopher Aristotle suggested that the earth is a unique place and it was the center of the whole universe. This was Aristotle's opinion based on his realization of the surrounding world and not on any scientific evidence. That's why we call it Aristotle's philosophy. 100 years after the birth of Jesus Christ, Ptolemy supported this geocentric worldview of Aristotle, and the Roman Catholic Church adopted this view and decreed that any opposition to Aristotelian view would be against the religion. Thus, the plurality of the world was lost. But religious hegemony cannot stop progress of science for long. The evidences collected by various scholars started contradicting Aristotelian views. Just before his death in 1543, Polish mathematician and astronomer Nicolaus Copernicus published his theory that the world is actually heliocentric and the earth moves around the sun. Now, Giordano Bruno openly advocated the Copernican theory. He further suggested that all the lights in the night sky are similar to the sun and they too have planets around them, and those planets may have life. For such revolutionary opinion, unfortunately, Bruno was burned alive on the street of Rome on 14th February 1600. In the meantime, astronomer Tycho Brahe collected a large amount of data on the positions and motions of the celestial objects, and based on those astronomical data, Johannes Kepler derived the laws of the motion of the planets around the sun. At the same time, by using the newly discovered telescope, Galileo Galilei also observed the celestial objects and discovered the moons of Jupiter, and he too supported Copernicus' theory. Thus, the plurality of the world was re-established. The eternal curiosity of mankind about alien rekindled, and we again started asking, is anybody out there, or are we alone? But the search, the imagination, and speculation of extraterrestrial life were somehow limited to the moon and to the Mars because of technological limitation. The human civilization needed to wait for another couple of centuries before it progressed into the cosmic communicating civilization. So, after a few years of the discovery of radio wave by Hodge, Sir Jesse Bose invented and demonstrated radio transmitter and receiver in Calcutta Town Hall. A few months after that, Marconi too invented radio independently. After about 40 years of this invention, a young engineer at AT&T Bell Laboratory in the USA, Carl Jansky, invented radio telescope while trying to find out the source of disturbances in transatlantic radio communication. Now, an improved version of this radio telescope called Big Ear was constructed for receiving signal from alien, and the scientific search for extraterrestrial intelligence, or what we know today as SETI, began in 1957. A few years later, astronomer Frank Drake initiated Project Ojma. Now, from Project Ojma to very recent breakthrough initiative, in which I am one of the signatories, there has been hectic search for 6 decades to detect radio signal from aliens, but without success. So the question arises, does alien civilization really exist in our galaxy? If so, then what should be the possible number of such civilizations that can communicate with us? Even a rough estimation of the number may tell us how frequently we should receive signals from aliens, or we shall never receive any signal from anybody outside the solar system. So a probabilistic argument for the estimation of the number of alien civilization in our galaxy that have the capability to communicate with other civilization was given by Frank Drake in 1961. This is famously known as Drake equation. This is not a derived equation. The whole purpose of providing such expression was to generate interest on the search of aliens. Later on, many researchers presented modified version of this expression, but the main idea remains the same. Here, n is the number of civilization in our galaxy that have the technology, capability to communicate with other advanced civilization. And R star is the average. This n, I think there is a problem with the.
There is no problem.
Can you see this?
Yes, yes.
Oh, I can't see it. What happened to? Yes. So, So Earth star is the average rate of star formation in our galaxy. Fp is the fraction of the stars that have planets. Ne is the average number of rocky planets in the habitable zone of the host stars. If L is the fraction of habitable planets that actually harbor life. If I, the fraction of life hosting planets that have intelligent life or civilization. If C, the fraction of civilization that can communicate with other civilization. And finally, the Lth is the length of time for which such civilization emit detectable artificial signal into the space. So the number of communicating civilization depends on these 7 factors. Now let us discuss one by one how big or small are these parameters. The first parameter R star can be derived from the observed value of the rate of star formation per year, which is actually the amount of interstellar gas and dust that are used to form stars every year. Now, dividing this by the mean mass of the um, newly born stars, we get the mean rate of star formation per year in our galaxy. So by taking the mean of this value, we can put this R star as 2. The next parameter is the fraction of star in our galaxy that host planets. Although Bruno, Sir Isaac Newton, and other scholars realized that there could be planets around the other stars, a search for such exoplanet was not possible due to the lack of technology, mainly due to the unavailability of photographic plates. The first systematic and scientific investigation was reported by the then director, Captain William Stephen Jacob of Madras Observatory, which was established by the British East India Company in 1786. This observatory was shifted to Kodaikanal Solar Observatory in 1900, which becomes part of the present Indian Institute of Astrophysics in 1971, and I am a faculty of this institute. Now, Captain Jacob found that the two stars in 70 Ophiuchi binary star system were not following exactly the Kepler's law. From the anomaly in the orbital motion of this binary star system, Captain Jacob inferred the presence of a Jupiter mass planet as the third component of the binary star system. This was supported by a few astronomers in USA, but later it was found that Captain Jacob did not include the atmospheric effect appropriately. Nevertheless, this is now considered as the first false alarm for exoplanet, and this work inspired many astronomers to search for exoplanets. But for the next 140 years, no planets around stars other than the sun was confirmed. Although many astronomers reported discovery of exoplanet, but all turned out to be false alarm. Finally, in 1995, Michel Mayor and his collaborator Didier Queloz of Geneva Observatory discovered the first confirmed exoplanet around a star 51 Pegasi, for which they were awarded Nobel Prize in 2019. But unlike the way we directly see the solar planets, planets around other stars cannot be seen directly because they are hidden under the intense brightness of their parent star. So astronomers uses indirect methods to detect and confirm the presence of planets around a distant star. Mayor and Queloz uses a method called the radial velocity method or the Doppler method. Now, what is this method? So radial velocity or Doppler method was proposed by Otto Struve in 1952. When two celestial objects of equal weight orbit each other, they don't rotate around the center of any of the two objects, but around a common center called barycenter, which is the middle of the line joining the center of the two objects. Now, if one object is heavier than the other, then the barycenter shifts towards the heavier object. In a planet star system, the star is so heavy as compared to the planet that the barycenter is located inside the star. This causes a wobble in the star that hosts a planet in the that hosts the planet. Now, if the planet is orbiting at edge on view of the observer, then this motion of the star appears to and fro. And this is called the radial velocity of the star. Now, astronomers collect the starlight under such condition through a spectrograph and detect the periodic Doppler shift in starlight by monitoring the shift in the dark vertical line caused by the absorption of starlight by the material present in the outer layer of the star. Now, from the periodic Doppler shift, if there is static, then there is no movement of the black line. But from the periodic Doppler shift towards red and blue of a particular absorption line, the radial velocity of the star is measured and the presence of the planet is confirmed. So Jupiter imparts a radial velocity of 12.4 meter per second, and the Earth imparts a radial velocity of only 10 centimeter per second to our Sun. Obviously, in order to detect such small velocity, a spectrograph with very high resolution is needed. Mayor and Queloz used a high-resolution fiber optics fed cell type spectrograph called LOD to discover the exoplanet 51 Pegasi b. The planet is half the mass of the Jupiter, but it is so close to its star that it completes one orbit in 4 days instead of 365 days. As a result, it imparts a maximum radial velocity of 56 meters per second to the star, which was easy to be detected by the instrument LOD. However, the most popular method through which most of the 5,000 exoplanets are discovered till date is called the transit method. In this method, astronomers continuously monitor the brightness of a star. If the star hosts a planet which orbits edge on with respect to the observer, then it blocks a tiny part of the stellar disk and hence reduces the brightness of the stellar periodically while crossing the star. Such periodic changes in the brightness of the star implies the presence of a planet. Now, a statistical analysis of the number of exoplanets detected by using transit method indicates that about half of the stars in Milky Way galaxy host a planet or a planetary system. So now, by using the Indian telescope, we too observe the planet hosting stars through transit method and detect the signal of the exoplanets. But this method can detect only those exoplanets that orbits almost edge on with respect to the observer. So another detection method based on the principle of Albert Einstein's general theory of relativity can avoid this bias inherited by the transit method. This method is known as gravitational microlensing method. If a distant star is almost exactly aligned with a nearby star and the observer, the nearby star acts as a lens magnifying the light of the distant star. This happens because the light of the distant star bends by the gravitational field of the nearby foreground star. Now, the foreground star. Now, if the foreground star hosts a planet, the planet also acts as a lens. By monitoring the magnification of light of the distant star, an exoplanet around the foreground star is detected. The statistical analysis of the exoplanet discovered by using this method implies that all the stars have, by average, one planet. So hosting planets is a rule of a star in our galaxy at least. Now the next parameter is the average number of rocky planets in the habitable zone of a planet hosting star. But what is a habitable zone? Circumstellar habitable zone or Goldilocks zone is a region around a star that is located at such a distance from the star that the thermal condition of the region is appropriate for water to exist in liquid state. Clearly, the distance of the zone from the star depends on how hot is the star is. So, if we consider only the brightness of the heat emitted of our sun, then the mean surface temperature of Venus should be 55 degrees Celsius. The mean surface temperature of the Earth should be about 5 degrees Celsius, and that for Mars will be minus 47 degrees Celsius. Therefore, Venus, Earth, and because of an elliptical orbit, sometimes Mars would have appropriate surface temperature for water to exist in liquid states. But we know all planets have a reflecting property called the albedo. 30% of the sunlight received by Earth is reflected back to space. Mars reflects around 25% of sunlight, and Venus reflects a whopping 75% of sunlight it receives on its surface. So, if we consider the reflectivity or albedo of the surface or albedo, then the surface temperature of Earth would become about minus 18 degrees Celsius. Venus will become minus 43 degrees Celsius, and Mars will become 23 degree Celsius. As a consequence, none of the planets in the solar system would be habitable. But we know water on Earth exists in all these states, as the mean surface temperature of Earth is about 15 degrees Celsius. So why? So that's because of the greenhouse effect. Part of the visible light from the star gets absorbed by the solid surface and the surface warms up. The warm surface radiates in longer infrared wavelengths. This comparatively weak radiation or of longer wavelength while trying to escape the planet gets scattered several times by water, carbon dioxide, methane molecules in the atmosphere and hence gets trapped. The trapped radiation increases the atmospheric temperature. Earth's temperature increases by about 30 degree due to the greenhouse effect. Since Mars has a thin atmosphere, the greenhouse effect alters the temperature very little by about 5 degrees. On the other hand, presence of 95% carbon dioxide in a very thick atmosphere of Venus causes runaway greenhouse effect that raises its surface temperature to a whopping 464 degrees Celsius. Thus, even if a planet is located in the habitable zone of its parent star, the nature of the planetary atmosphere determines if it can have ambient temperature appropriate for water to exist in liquid state. Now, quite a few rocky planets in the habitable zone of their host stars are detected till date. Analysis of data obtained by NASA's Kepler Space Telescope indicates 2 to 12% of stars, mostly the smallest and the faintest ones in our galaxy, has rocky planets in their habitable zone. About half of Sun-like stars should have a rocky planet in their habitable zone. So the average number of rocky planets in the habitable zone of planet hosting stars could be at least one. But can all these rocky planets in the habitable zone really harbor life? That leads to a more fundamental question. What is life? Now, our understanding of life is based on the billions of living species we know on the Earth. But can we define even Earth-based life? When I search for the definition of life, I stop counting up to 95th definition, and that excludes the philosophical definition. So there is no universal definition of life. If someone asks you what is water, you reply that it's a molecule made of 2 hydrogen atoms and 1 oxygen atom. It can even be expressed as a formula H2O. By applying our knowledge on atomic and molecular physics and a little bit of quantum mechanics, we can derive all the physical properties and chemical properties of water from this formula. However, such a fundamental formula for life does not exist. And so, we can only describe various essential functions that distinguishes a living species from a non-living one. Basically, life is an ensemble of organic materials governed by self-sustaining synchronized system of chemical processes and characterized by metabolism, replication, and evolution through natural selection. Now, organic molecules are compounds made by mainly carbon, oxygen, and hydrogen. The origin of organic materials on Earth is a controversial topic. About 90 years ago, two scientists, Oparin and Halden, postulated that organic materials were synthesized on the Earth out of the available inorganic materials under some conditions that prevailed during the early epoch of the Earth. About 70 years ago, Urey and Miller synthesized amino acid. the building block of life in laboratory out of a mixture of inorganic materials by simulating the conditions similar to that prevailed during the early period of the Earth. The result of this experiment convinced people that life originated on the Earth itself through chemical evolution. But recently, we have discovered various kinds of organic materials being imported to the Earth by meteorites. As the infrared astronomy progressed, we also discovered that the interstellar medium is a huge factory of producing organic molecules. Interestingly, Urey-Miller experiment and future upgraded experiment produced only one out of the 20 amino acids that makes protein in any living species. So there is a controversy and differences and in opinion about the origin of life. Did life originated on the earth through chemical evolution or had it come from the space? Nobody knows for sure. Now, metabolism is a biochemical process through which a living cell receives, stores, and releases energy in its battery called mitochondria. Replication is a process through which a living cell makes an exact copy of itself and also transfer genetical information from one generation to other. And evolution is the response of the species to the environment. If we find a cat and dog in another planet, we can infer that the planet has several cats and dogs and their progenitor. But if we don't, we can safely infer that the animals were imported from other planets. However, a description is never complete and many a times controversial. So for astronomical searches for life, NASA has provided a working definition for life, and that tells that life is a self-sustaining chemical system capable of Darwinian evolution. Now, even if we assume that life may origin in all rocky planets in the habitable zone of the host star, survival of life requires several favorable conditions. An extremely rare combination of astronomical and geological coincidences enable life on the Earth to survive and evolve. The solar system is configured in such a way that it protects life on Earth from frequent collision of comets. The short period comets are born in a disk-like region filled up by ice and rocks at the edge of the planetary system. This region is known as Kuiper belt. On the other hand, the entire solar system is surrounded by a spherical gaseous region called the Oort cloud. Long period comets are born here. Many of these short and long period comets could collide with the Earth while they orbit in a highly elliptical orbit around the Sun. In our solar system, the small rocky planets, including Earth, are located near the Sun, and the giant gas planets such as Jupiter and Saturn are orbiting far away from these rocky uh, inner planets. So, because of the strong gravity of these giant planets, most of the comets coming from Oort cloud and Kuiper belt are attracted towards the collision with Jupiter and Saturn. Thus, the rate of collision by comets with Earth reduces significantly and the Earth is protected. The Sun occasionally flares up, throwing out a large amount of energetic charged particles. These charged particles cannot penetrate into our atmosphere because the Earth has a dipole geomagnetic field. The little amount of charged particles can enter the atmosphere only through the magnetic poles, causing the spectacular aurora. So if there was no geomagnetic field, the energetic charged particles could enter the earth in all direction, causing chemical changes in the atmosphere and would destroy the living cells. Now, carbon dioxide in Earth atmosphere plays a double role. It reflects a good amount of sunlight to space, making the Earth cooler. At the same time, it acts as an active greenhouse effect agent to keep the Earth warm. So a balanced amount of carbon dioxide needed to be present. But carbon dioxide mix up with rainwater to form carbonic acid and dissolve into silicon rocks to form carbonate sediments. Under such process, the carbon dioxide would have completely depleted in the atmosphere in 10 million years, making the planet much cooler. But because of active volcanoes and earthquake, carbon dioxide is released into the atmosphere, keeping the balance in a million years. This is known as carbon silicate cycle. So volcanoes and earthquake also reprocesses the minerals and the gases in the earth. Therefore, geological activities help in maintaining a habitable environment of the earth. Usually, we think that volcanoes are very dangerous. Plate tectonic is very destructive, but without plate tectonic and without volcanoes, life could not have survived on Earth. So this is why on Mars there is no plate tectonic or volcanic activity, and the mineral has not been processed, and there is no cycle of carbon dioxide or any other minerals. Now, the spin axis of the Earth is presently tilted at 23.4 degree with respect to the normal to its orbital plane. This tilt causes seasonal changes on the Earth. But this tilt angle or obliquity is not fixed. It varies from 21.5 to 24.5 degree in 41,000 years. Earth's orbit shape and plane also changes in 100,000 to 400,000 years. These small dynamical changes enable the planet to have a stable climate over a long period. This is possible because of the presence of a large moon. The moon formed from the ejecta of a collision between the primitive Earth and a Mars-sized object called Theia, about 60 million years after the birth of the Earth. Before the moon was formed, the Earth was spinning so fast that a day was less than 10 hours long. The moon slowed down the spin and helped the Earth to maintain a small tilt angle through a tug of war with the gravitational pull of mighty Jupiter and Saturn. Therefore, moon not only causes tides and atmospheric circulation but also prevents a chaotic seasonal changes and help the earth to maintain a favorite climate for life on the earth. However, we may never know if an exoplanet is lucky enough to have so many favorable geological and astronomical conditions that support life. Therefore, in order to find out the fraction of habitable planets that actually harbor life, that is FL, we need to search for signature of life or biosignature in the atmosphere of these planets. Now we can detect the atmospheric composition of Venus and Earth and Mars by passing their light through an instrument called spectrograph. The spectra obtained from these three planets show the presence of carbon dioxide in the atmosphere. But in addition to that, the spectrum of Earth clearly shows a signature of water, oxygen, and ozone molecules. Now, at the initial stage, Earth did not have any free oxygen molecules because all the oxygen atoms combined with other elements to form oxides such as water, carbon dioxide, silicon oxide, etc. About 3.9 billion year ago, cyanobacteria, a kind of bacteria, appears on the Earth, which through photosynthesis produce great amount of oxygen molecules, and the chemical composition of Earth's atmosphere was drastically changed. These oxygen molecules get dissociated into oxygen atoms by solar ultraviolet rays at the upper atmosphere of the Earth. So one oxygen molecule combined with one oxygen atom to produce the ozone molecule that is protecting us from the intense ultraviolet rays of the sun. Therefore, oxygen and ozone molecules serve as biosignature. Methane also serves as biosignature in an oxygen-rich atmosphere. Chemically produced methane cannot survive on the earth as it reacts with oxygen to form carbon dioxide. But the equilibrium in such chemical reaction breaks down if methane is produced biologically. Thus, signature of methane serves also as a biosignature. However, obtaining the spectra of habitable exoplanet is not straightforward, as the reflected light from exoplanet cannot be seen directly. So, to obtain the spectra of exoplanet, first the spectrum of the host star is taken when the planet is not traveling or blocking its light. Then the spectrum is taken during the transit epoch. Since a part of the starlight passes through the atmosphere of the planet, this spectrum carries the signature of the atmosphere of both the planet and the parent star. Now, subtracting the first spectrum from the second one provides us the spectrum of the exoplanet. This is called the transmission spectra. We numerically model such spectra that can be compared with the observed transmission spectra and can recognize biosignature if present. Unfortunately, available observational facilities are not sufficient to obtain transmission spectra of rocky exoplanet in habitable zone, but the recently launched new generation space telescope, James Webb Space Telescope, is expected to obtain the much desired transmission spectra of a habitable rocky planet. At the same time, we'll get three giant ground-based telescope mm, with the help of such powerful next generation telescope. We hope to detect biosignature at some exoplanet during the present decades if life really origins and evolves on other worlds. Therefore, right now we have no idea, not even a rough estimation on the fraction of planets that harbors life. The next two parameters strongly depends on this parameter, that is FL. So if you assume that that life originated anywhere, would certainly evolve into intelligent life, then the fraction of life hosting planets that harbor intelligent life should be 1. But evolution may not be so deterministic, and the evolution history on other planets may not necessarily be the same as that on Earth, such that intelligent life would certainly appear at some stage at some stage on a life hosting exoplanet. However, it will not be illogical to consider that if intelligent life appears in some exoplanet, it may, due to its own necessity, will progress into an advanced civilization like us, and ultimately would be capable of communicate with other alien civilization. Note that out of several species in the genus Homo, only Homo sapiens or human survived, and it is the only species that is intelligent enough to communicate with others in the universe. So that is why the product of the three factors is not zero in our galaxy, because Earth has life, at least one planet has life, we know, and it has a communicating civilization. But we don't know how small or large it is. So if we consider that an exoplanet needs the extremely rare coincidence of the favorable condition that enable life to survive on the Earth, then the number of alien civilization that can communicate will be extremely small. Possibly we are the only such cases in our galaxy. On the other hand, if we consider origin of life is quite a common phenomena in our universe, and life may somehow manage to survive without those favorable conditions that our planet enjoys, then the number could be several millions. However, in estimating the number of alien civilization in our galaxy, the last parameter L, which is the average duration of those civilizations that can continue communicating, is overestimated in the principle of mediocrity. Now I shall discuss it in my last slide. So space, although it's a vast empty place, it is often a dangerous place. Although the giant planets Jupiter and Saturn are protecting us, but a few comets may escape the clutch and hit the Earth. Collision by a comet or a giant asteroid would cause evaporation of the ocean, may block the sunlight by forming a thick dust cloud, and even may alter the spin rotation angle of the Earth. Collision by a comet about 60 million years ago during the Jurassic period is believed to be responsible for the extinction of dinosaurs and all other large species. Now, supernova explosion in the last stage of the evolution of nearby heavy stars, or just one gamma ray burst in our galaxy, the most powerful source of energy in the universe, uh, caused by the collision of two neutron stars, may destroy Earth's biosphere permanently by intense X-ray and ultraviolet ray. The Sun is a gentle middle-aged dwarf star without much activity. But if due to any strong activity in future, it emits a giant flare, the geomagnetic field may be permanently destroyed, causing energetic charged particle from the sun to penetrate and damage the biosphere. There could be geological disaster as well. A super earthquake or a super tsunami or a gigantic volcanoes may cause extinction of developed life on the land. Although the possibility of the occurrence of such astronomical and geological calamities is very small, mass extinction on this planet occurred at least 6 times in the past. But the most imminent threat may come from human civilization itself. An accidental nuclear or chemical or biological wear may destroy the entire human civilization and causes irreversibly damage to the biosphere. Rapid extension of industry and use of fossil fuel may increase the amount of carbon dioxide in such a great extent that the carbon silicon cycle may be destroyed. Global warming may cause hole in the ozone layer and hence protection from the solar ultraviolet radiation may break down. So the progress in civilization with irresponsible use of technology may cause self-destruction. All these astronomical, geological, and man-made potential disasters can cause the duration of communication by our civilization or any similar alien civilization quite short. Hence, the number of cosmic communicating civilization in our galaxy may reduce significantly by destruction. So this we need to keep in mind. But whatever be the possibility of the existence of alien civilization, whatever be the number of advanced civilization, the fact is that till date we have no evidence, no signal, no signature of life anywhere outside the Earth. Believe it or not, no signal yet from alien, no signal of any unnatural activities, even in the farthest part of our galaxy, implies that we are alone in this vast cosmic arena. Accept it or not, we have no place to migrate, nobody to help from anywhere if global disasters strike us. Our home, the planet Earth, is so special yet so vulnerable, so crowded yet so lonely, so common yet so unique, so insignificant yet so great. We all are in the same boat, a mote of dust suspended in a beam of sunlight and floating in the vast emptiness of space. We must not allow our ego, our ignorance, and our irresponsibility to sink this boat. So, irrespective of our caste, creed, country, it's our duty, it is our responsibility of each and every member of our species to protect this rarest of the rare planet so that generation of children can keep on smiling. Thank you.
Thank you. Thank you very much for this excellent talk. And you covered a lot of aspects. And now floor is open for any queries. So
So if anybody is interested to know further, you can collect my book, which is published by Springer, Worlds Beyond Our Own. It is available in Amazon also, and I will request Rajesh to get a copy for their physics department
yes,
library.
yes.
This book will be
Yeah.
very helpful and written in a popular way. It doesn't need any expertise on this subject.
Okay, okay. We will. Yes, yes.
Thank you.
Yeah, so yes, Sarthak Agrawal. Yes, before we proceed for queries, as per request from Professor Sujan Sengupta, we should avoid asking questions related to mythology, astrology, and so on. Just scientific questions we should put. Is it okay, Professor?
Yes, sure.
Yeah. Yes, yes. So somebody has written the text message. Yes, Sarthak Agrawal. Are you there, Sarthak Agrawal?
Yes, sir. So just
Yeah,
wanted to
Yeah, please
uh,
go ahead.
ask about this concept I read about, which is known as the Fermi Paradox.
Yeah.
about if extraterrestrial life, if it exists, then why haven't they contacted us, or why haven't we reached them yet? So would you like to explain something on that or add something to that,
Yeah,
comment
so
on that?
that is the whole thing. I have got it. See, the thing is that our galaxy has 200 billion stars. Okay, now in the whole universe, there are at least 200 billion galaxies. So 200 billion into 200 objects. And if one star have, by average, one planet or even three planets, then there should be, by probability, there should be some of the planet which may be very similar to the Earth. But still, we don't see them. We don't see even any activities then. So the problem is that the vastness. The thing is that our galaxy, from one corner to other corner, light takes 1,50,000 years to travel from one corner to other corner of our galaxy itself. So if and suppose our solar system, the distance of our solar system from the nearest edge of our galaxy is 20,000 light years. So if at the edge of our galaxy some civilization sends a signal, it will take 20,000 years to reach us. And by that 20,000 years, that civilization will be so advanced, or they might have destroyed themselves itself. So those are the problems. So what we discussed with this, that how many communicating civilization will be at present, not necessarily that they can communicate with us, but while communicating with us, this distance is a big factor. So, as I have told in my talk, that our radio receiver and our radio transmitter was discovered about 150 years ago. So the signals, the artificial signal from our planet has traveled only 150 light years. So in 150 light years, we have not found any habitable planet or anything there which has any signal or anything. So now there are two parts of this search. One is to get the signal from intelligent life, that is the SETI, and I was one of the signatory for this breakthrough initiative. The second part, that is the main thing of my research in astrophysics, is to find out, instead of intelligent signal, we need to find out the biosignature in the atmosphere. So that means that whether a planet has life, intelligent or not, even unintelligent life. So the biosignature. So we are right now, we are discovering as many planets as possible. The first step, after the discovery of Michel and Mayor, Michel Mayor and Didier Queloz, there are 5,000 planets has been discovered. Now we are pinning down that how many of these planets are rocky and in the habitable zone. Then we will take spectrum of those planets and find out if there are any biosignature. If we find out any biosignature, then bingo, we know that life exists elsewhere. And then the Fermi Paradox will be solved. And unless and until we find out any signature anywhere in the galaxy, we cannot say anything about life. It may happen that we are the first civilization, intelligent civilization in our galaxy. It may happen that the probability is so less that we are the only intelligent life. But personally, I believe that there are life many places, in many planets. The only problem is communicating. If not intelligent life, life in nascent form, life in bacterial form, or even apes or monkeys which has not yet evolved into intelligent life, may certainly exist. So we have to find out the biosignature.
Got it, sir. So one another small thing. Is it possible that some advanced form of life have discovered ways to travel faster than light and maybe uh,
No, no. The laws of physics are universal. So what if you throw an apple to the sky and it will fall to you because of Newton's law? The same principle will be followed at the corner of the universe. The Maxwell laws, the Faraday's laws, all are universal, and therefore what you are seeing it here, it will be valid there. So there will be no possibility that somebody will discover faster than velocity of light.
okay, sir, got it. Thank you.
Yes, Ritvik Tiwari. Ritvik Tiwari, are you there?
Yes, sir.
I can see your. Yeah,
Yes,
please.
sir. I had query regarding the origin of the moon. Can you, according to you, what do you think is the most plausible explanation for the origin of moon?
Yeah, we have geological evidences, no? So the people went, Apollo's crew and other people, they brought the stones and then we have detailed numerical simulation. And you mean to say that how the moon was born, right?
Yes, sir.
So there were many theories, but this theory that the moon was formed by the collision of a Mars-sized thing is supported by many evidences and believed by many people, because there are geological evidences. When we bought the stones from moon, then we found that they are very similar to the Earth kind, and also the numerical simulation of the early Earth and the orbital motion. All those things indicates that our moon is formed out of this collision. But there are several moons in our solar system. Not necessarily all the moons are formed in the same way. Like the Deimos and Phobos of Mars, they are very small ones. So they might be asteroid and they're captured by the Mars. On the other hand, the massive Ganymede, Titan, those planets, they are formed just like a planet is formed. So once the giant gas planet was formed, Jupiter and Saturn was formed, the leftover dust and gas, they again collapse gravitationally and they form the moons. On the other hand, Triton may be captured from the Kuiper belt. It captured dwarf planet or something like that. It captured like that. So this Pluto and Charon, it may be captured from the Kuiper belt. So we have hundreds of moon in our solar system, and they form in different way. But when you ask for the moon, so there is a question that exomoon. So actually our group has suggested a way to discover exomoon. We know that if solar system has so many moons, so the exoplanet should have also moon, but unfortunately they will be so small, their signature will be so small that not a single one is detected yet. But we have now shown that by JWST, we may possibly detect exomoon. Now, why it is important? That if even there is no rocky planet in the habitable zone of a star, if there is a gas giant, Jupiter type of planet in the habitable zone of a star, so it cannot have life. But a rocky moon orbiting this gas giant may harbor life, because it may have the appropriate temperature to have water on its surface. So in that case, it will be just like your Avatar movies, Pandora. So all kind of thing, whatever few decades ago we thought as science fiction, now coming to us, unveiling to us one by one, and our entire concept on planetary system and planets has been completely revolutionized after this discovery of the first exoplanet, and subsequently several planet was discovered, and that's the reason why Michel and Queloz was given the Nobel Prize.
Thank you, sir.
Maybe we can take one more question. If
I can take, yeah, no problem. There's no problem if there are problems. That is the whole purpose of the talk, yeah.
Yes.
Yeah. Go ahead. So no problem, no question?
Yeah, probably they don't have any other questions right now. But anyway, if any of you want to contact Professor Sujan, yes, Professor Topame Gua Sarkar.
Hello, Professor Sujan. Thanks for the beautiful talk. I mean, it was really nice. Can you hear me?
Yeah.
So there's this scar which is also coming up with some SETI project, right? There's one of the science goals is also SETI. I mean, what kind of radio signals do we expect if it is believed to be something which is coming from life form? I mean, in the sense that how do we distinguish radio signals from something which is not anything which is either something from the Earth itself or I mean.
Very good question. So what happened for the last 6 decades? People are putting their telescope to get the signal. So Breakthrough Initiative, what they did, what is now SETI's form, they, Mr. Yuri Milner, a Russian billionaire, he spent $100 million dollar, and by using that money, the astronomers has bought a large amount of time from this big radio telescope. So what happened? The SETI project was not financially supported by NASA. It supported partially, but there was no result. So it was not supported. So the private companies is coming out. Now your question is that how you will distinguish the radio signal from the natural signal to the artificial signal. So first and foremost is that any intelligent people, the signal from any intelligent life will come in a very extremely narrow band. Will be by one hertz or one micron type of thing, because it needs lot of energy to send. So the natural radio signal that we get from sun or from stars, from galaxies, are in broadband. Their spread is over a few hertz wavelength. But if we get a artificial signal, then it will be in an extremely narrow band. This is one point. The second point will be there. It will be a systematic. It will be, since it is a signal, it will be systematic. Either it will be periodic or something we do not know. So this is the problem, that what type of signal we are searching, something that we don't know. But at least we know that it will need enormous energy if they send it by broadband. So we are searching out of all the broadband wavelength, we are searching if there is any extremely narrowband signal, and if that narrowband signal has any pattern that can distinguish it from natural signal to artificial signal.
Even like fast radio bursts, I mean, they would also FRBs.
No, but that is highly energetic. So to produce that type of energy, those people, the intelligent life, if they have it, they need the entire star to produce that energy. Say
Right.
that
Okay.
starburst needs a lot of energy. So probably the intelligent people will not spoil so much or waste so much energy just to communicate.
Right.
So this rapid burst is a natural phenomena that is now known. It is not by intelligent life. There is another possibility that if they are too much intelligent, they may communicate among themselves through neutrino, and we may not get it. Neutrino has a property that it can penetrate anywhere it will go, and it is almost the velocity of light. So that can be also done. So the thing is that there are two ways: either there is life, but there is no intelligent life, and so we need to search for biosignature, not for the signal. The second thing is that the intelligent is too much intelligent, that they ignore us, and their technology we are not capable to interfere or to interpret that is another thing. But then, from the art, if we follow the art, the civilization increases, means advances, and the technological need destroys it. So in fact, if we go in this way, then one day very soon we are going to destroy each other by nuclear bomb or anything, or our energy requirement will be so high that we will destroy each other. So Kardashev, a Russian scientist, has proposed a few kind of civilization: civilization 1, civilization 2, civilization 3, like that. Under that category, we are not even in civilization 1. So civilization 1 is those civilization which can use the entire amount of energy that is received by their planet from their host star. Civilization 2 is that those civilizations who are so advanced that they can use the entire energy emitted by their parent star. Civilization 3 is those civilizations which are capable to use the energy of the entire galaxy. That means they uses the black holes also in their form. So those type of people are there. Then only they can make this radio burst or anything. So
Right.
these are the three categories, but these are highly speculative. These are not hard science or anything. These are highly speculative things. Means it is in science fiction era. Many people give many idea, but nevertheless, this tells us that we should be very careful as our civilization advances. We are not going for good, or we are not going for better way. We may go even by anti civilization 1, 2, 3, like that, and destroy each other. And since we don't have any place to go out, or there will be nobody to help us if in case we are in problem, so we have to be very careful. So the search for extraterrestrial life, the search for extraterrestrial intelligence tells more and more to us that how rare is our planet and how imminent, how urgent it is to protect our planet is this vast cosmic arena. Once it is destroyed, gun case done. Nothing, no, never ever the Earth will, life will emerge out.
Thank you, sir. Thank you.
Okay, so with this, I think it's time to close this seminar. So once again, on behalf of the physics department, I'm thankful to Professor Sujan Sengupta for giving such a wonderful talk and very thought-provoking talk. And in near future, we would be happy to host you in WITS Pilani. So whenever you are around Pilani.
Thank you very much for your invitation to deliver this lecture. And
Yes.
thanks to all the people who listened to the talk and interacted. Whatever question is asked was a very great question. And it usually happens because you are in the bits. I give public lecture, popular lecture, all kind of, because the subject is hot. Several type of questions come. Even people start writing the questions before my talk starts. So in that way, I'm also glad because it is a both-way train, both-way ticket. And of course, I'll be very glad when the situation completely normalizes. Definitely, I will go to WITS, one of the premier institute in the country, and I will give another lecture. Maybe by that time, JWSST will be, you know very well, it has been launched already, and very soon it will be operational, and very soon we will get data, and we are expecting what type of wonder it shows to us. So by the time I will go, I think I will have some new information for you on the signature of life elsewhere.
Okay. So
Thank you.
yes. So just before I conclude, I want to tell you about that we are organizing this semester this online talk on Nobel related subjects. So you are the fourth speaker who has delivered this talk. So we started with the Professor Deepak Mathur, and then followed by two more speakers, and the fourth one is yourself. And probably we will have three more talks under this colloquium series. So we are again thankful for that. And please send us about your book information so that we can proceed accordingly.
Sure, you can get it from Spinger. If you just
Okay.
type the name Sujan Sengupta books
Okay.
or Sujan Sengupta, then you can get it from Amazon, from Flipkart, everywhere it
Okay.
is available.
Okay.
So it
Okay.
is by Spinger International, and if you Google it, the first thing it will come the book.
Okay. Thank you. So with this, we can disperse. Thank you very much, and I will send the recording of this lecture. And if you allow me, then I will put it on my physics department's
Yeah,
YouTube
please put it.
channel.
Please put it so that other people can hear it who have missed it there. And I think I have seen you have a Facebook account also. So if possible, put it there also.
Okay.
Okay, so that the message that I conveyed in today's talk is not really on life or outside. It is the importance of our planet. And
Yes.
this message should go to each and
Yeah.
everybody.
Yes. Thank you.
Thank you. So I am leaving. Okay.
Okay. Thank you.
Thank you. Thanks a lot.